Welcome to Physics Exam Prep. If you're new here, just so you know, we use a very structured approach for tackling real exam problems. Every tutorial is divided into question interpretation, logic chain, solution, summary, to make your learning as effective as possible. In this video, we are looking at a tough algebra-style problem. And yes, it shows up almost every year in both SL and HL exams. Don't panic. I will walk you through a trick that ensures you don't drop marks when you see similar ones. You can pause here and think about what kind of relationships the four graphs might represent. Alright, let's first identify the type of relationship each graph shows. Graph A is a straight line passing through the origin. This means R is directly proportional to T. R equals to KT. This is the mathematical expression. K is a constant. Next, graph B curves upward. So this is a quadratic equation. R equals to KT square. Graph C and graph D look like exponential decay function. So the task is, use the information in the question to figure out which of these describes the relationship between R and T. What exactly is R? Is defined as the rate of change of kinetic energy. We've definitely seen kinetic energy before, but rate of change of kinetic energy might feel less familiar. No worries, let's break it down. Rate always means per unit time. For example, the rate of heat transfer means the amount of heat transferred per second. Here is another example. If you happened to take chemistry, the rate of gas produced means the volume of gas produced per second. So mathematically, rate of something is that thing divided by time. That's the basic idea. And this is the mathematical expression for R. You see, the expression already contains T in the denominator, but we can't just simply conclude that R is inversely proportional to T. This is because V, the final velocity of the object, is a function of T. And we need to get rid of V. And the clue lies in the x-axis variable. As for the x-axis, T is the time taken for an object to fall vertically. This implies that the x-axis is associated with SUVAT equation. So let's look up for the SUVAT quantities. The object falls from rest, tells us the initial velocity of the object is 0. In vacuum means no air resistance, so constant acceleration due to gravity. With these conditions, we can find the appropriate SUVAT equation and sub into the R expression. Oh, that seems a lot. Let's zoom out and plant this question step by step. When you are asked about the relationship between two variables, the goal is to express the y-axis variable in terms of only constants and the x-axis variable. Here, the y-axis is R. The expression for R has constants 1/2 m plus v plus a denominator with t. The constants are fine. The only thing we need to handle is v. So what's the plan? First step is to have the expression for y-axis, and we already have it. Second step is to identify what's constant and what's not. We've already done it. The next step is to use x-axis information, in this case motion under constant acceleration, to get v as a function of t. So let's apply SUVAT. We know u and a from question interpretation. V and t are relevant to the question, as is not mentioned. This leads us to the equation v equals to u plus at. The last step is substitute this back to R, so that the final expression has only constants and t. That's a whole roadmap. You're doing great if you're following so far. Take a moment, try to finish the algebra yourself. Then we will compare in the solution. Alright, here we go. For the y-axis, we have the expression for r. For x-axis, we apply SUVAT and get the equation v equals to u plus at. We know that the initial velocity is 0, so it simplifies to v equals to at. Substitute this into the r expression and do the algebra. Notice that 1/2 ma squared is just a constant, so we can call it k. So the final expression is r equals to kt. That's a straight line through the origin. The answer is graph A. Let's summarize what we did. For any find the relationship problem, your job is to express the y-axis entirely in terms of constants and the x-axis variable. Here is a general plan. First, start by writing down the expression for the y-axis. It's usually something you already know, often from the formula sheet. Second, check which parts are constant and which parts are not. The non-constant variable is what you'll need to replace. Third, use the x-axis information to find an expression for that variable. Last, substitute this back into your original expression from step 1. That's the full roadmap. And just to be clear, if you asked a math teacher, they might say this isn't the most rigorous way to represent rate of something, but in physics, this method is good enough. If you get stuck somewhere, just drop your questions in the comments.